I'm just back from doing some field testing on a series of machines in the Pacific Northwest. It was supposed to be something different. I got redirected based on irrigation issues, which gave me a chance to test our October surprise. But in the meantime, I did attempt to do a podcast last week, and I've been doing this specifically in ChatGPT for a reason, and that is to give people an idea of what the tool's actually meant for. Now, it is a generative, well, they're calling it AI, but it's a generative machine learning or a generative AI system in which it makes assumptions and best guesses on the next, say, character or letter or wording, things like that. It basically generates a predictive model based upon a large library of existing materials. It's not something new. Okay, so it goes out and it's like an advanced search engine type thing, and it takes in what we're now calling prompts. So you have to come up with the question. And that's the same thing we struggle with in our CFA, right? Root cause failure analysis is coming up with the wording or what the question is that you actually want to answer without giving a conclusion, because generative AI will give you an answer. You tell it, this is what I want, and this is the response I want. It will make stuff up in order to give you what you want. It really wants to please the person who's doing the work. So as you'll see in my prompts, I ask very generic questions, and I have a target in mind. So this week, as I had meant to do last week, except for whatever reason, ChatGPT had fallen apart, meaning that I wasn't able to upload data and it wasn't presenting the charts I wanted and so on. If I run into problems, I'm going to stop and then I'll start up Jupyter Notebook and take the code that it tosses at me and then use that. Now, one of the things is it doesn't produce the data in CSV. Instead, it's going to produce it in text files, which hopefully get taken care of okay. And we're going to use the thing that I talk about this a lot when I say, forecasting models. Every time I see something new, it's always based upon either this jet engine data set or something else like it. These are free data sets. You can go to a website called Kaggle.com if you want, Kaggle. It's free for most of the data sets in order to get data sets and challenges and so on. There's a challenge I'm going to do this year with a significant prize, but I've actually addressed that one before, so it should be interesting how that comes out. But in any case, in this case, we're going to use the famous NASA data set model. And what this is, and it'll also explain how they come up with remaining useful life, right? So you need a history of data. And this history of data is used to generate mean time to failure. Okay, it's not a true prediction. Okay, it emulates what we do in as far as predictive maintenance, but that's why I'd produced the paper in 2010, which got reprinted all throughout IEEE, and that was called time to failure estimation, which was defined simply as predictive maintenance. But heaven forbid you use the word predictive in an engineering environment like that, where they go, well, if you're off by any amount, then your prediction is wrong. And I always picture somebody with a crystal ball, and that's accurate from one standpoint. The idea is to come up with the chance that something's going to occur. Now, this will be basically a time series type modeling project, and we're going to take a look at it. And time series means that I'm not going to use deep learning. If anybody says deep learning and time series in the same sentence, or says neural networks and time series, run. run fast. They don't know what they're talking about. So just be aware of that. Mostly what it is it's a methodology of looking at how many points are following prior points. So there's different ways of doing it. Or it might be a vector model, or it might be an ARIMA model, which is the variations of ARIMA models are used in financial predictions and the like. So we're going to take a look at this data, and they've provided a training set, a testing set, and then the final set. So we're going to do a train test split type model. I have to see if I can get, if I can convince ChatGPT to do what I want. Now we're not going to use, we are going to use ChatGPT 4.0 because I'm able to upload data easily. Otherwise, I have to do some other manipulations. I was going to do it as 0.1 mini, but so I don't use up my basically my engine that I'm using for some serious programming right now that we'll be announcing in about a week and a half. That's the secret. It's like, well, the result is not an AI ML system. However, and the challenge that I took, somebody said there's no way you can do it, so I did it. Was in 5 weeks develop a product from nothing with hardware that's useful in the field using AI as the programmer. So now, did I take everything? No, I'd say 70% of the work was done that way. The remaining 30% was going in and fixing all the mess ups, and I'm still working on that part. So the product is done. I just have to make sure that it's producing the outputs that I want. So I've been in the field testing it real time, so on and so on. And the last week before I go out there, I'm going to have dynamometers set up with known defects to see how it all produces it. And this will be the beta. So you will see that about a week and a half. Pretty advanced. I solved a major issue as part of it based on our research over the last several years. So anyways, getting back onto track. Here's the data set. I've already downloaded it to here. So this is, you can see there is text files. There's a README in there that basically gives the instructions or what all these files are. And then there's a paper that goes with the model. That's the original paper done to do some estimates. Now this has a series of sensors in each one. And the idea is to look at all of those sensors, figure out the features, and then what you do with it. Now, I'm going to let the ChatGPT do all of a majority of the work. Next week, we're going to do a true modeling system for, I'll do some simulated stuff based on projects we're doing with real SCADA data. I found out that most of the companies and organizations and universities that talk about doing SCADA data, they're actually using MATLAB models I created. And now it explains a lot because we are always using real data and doing real data science with that data. And we're getting results that are contrary to apparently static generated data from MATLAB or similar. So in any case, I've had a few surprises. I thought based on all the marketing stuff that's out there that everything was way beyond what everybody, what I was seeing. And maybe I was missing something. Nope, not missing anything at all. It sucks. So anyways, here's the data set. It consists of multiple, and when I was messing around and doing the practical parts of, I did like 43 AI ML certifications to make a point a few years ago in 6 months. And each course was 9 weeks in length, and there were 6 courses to each certification, and I would knock them out in a weekend. Basically was kind of it. So that was just to prove the point that nothing had changed from the 1990s. Sorry. Everything we're dealing with, the only reason that it's democratized, I think is the term that's being used now, is primarily because the chips that we're using, the hardware is now finally making it available to everybody, as well as the cloud, as long as you don't believe the people who are trying to tell you cloud is somehow secure. So in any case, we'll get into this. So it's a data set of jet engines and a series of 26 sensors, basically the unit number, how many times in cycles, the operational setting, and sensor measurements. Knowing this, I can set up features and see how things vary. And then it ends kind of when it fails. So what I'm going to do is I'm going to use the paper, and I'm going to use this, which is a text file. By the way, this link I'll put in the podcast page, as well as the YouTube page. I'll put that there so that you can access this if you want to try your own. Your results will probably be different than mine. That's one of the interesting things about generative AI. So here's our data set. I'm going to give it a README instruction. I'm going to upload just the test and train. Okay, so I'm going to say use these for testing, use these for training. And what just happened with there we go. The text, which will give instruction, and the paper, which will describe the experiment. Okay, and I'm going to tell ChatGPT that I want it to read the README to understand the files, and read the paper to understand the goal, and then use train for training a time series model, and then we'll upload the remaining actual data and see what it comes out with as results. Now, these are about 100 jet engines. Don't know how it's going to turn out. As always, I do these raw, meaning we're doing the podcast raw. If there's any pauses or anything else where we're going to have some time where whatever's happening, I will pause, but that's all I'm doing. I'm not doing anything else. The idea, of course, is to give people a chance to play with this stuff. So let's go ahead, and we're going to go over to ChatGPT, and I'm going to minimize things so you just see the main screen, because I have way too much stuff that I don't want to expose on the left-hand side. And we're going to start a new model here. I can do a memory thing, but basically, because you see here the workspace chats aren't used to train models, I pay for a enterprise version of ChatGPT, in which the work that I'm doing trains it specifically for what I'm doing. And it becomes very important to do that if I'm doing, let's just say, the project I'm working on has roughly 10,000 lines of code. And I need ChatGPT to remember everything I did. So that as I go through and I say, you idiot, do this, it comes back and apologizes for being an idiot and then corrects it wrong again. And then eventually I give up and just, fix it. So anyways, yeah, you can chuckle a bit because I do. So we're going to start here. And the part of the reason I'm using 4.0 and not the new ones here, like the 0.1 preview, which I just have to upload everything and say, give me this, and it will do the whole thing, and I just kick back. This is a big leap. But unfortunately, I can't upload anything, and I only have so many times. I think it's 50 prompts for what I'm paying for to be able to use it, and I need to save that for something else. So we're going to use 4.0, and we're going to upload the data, and we're going to upload it from the desktop. Here, let's get this off screen. Let's go to my desktop up here. Wrong desktop. Podcast demo. And predict 3. So I'm going to upload the damage propagation modeling, readme text, test. Now it's only going to allow me to upload 2, 3, 4, 5, 6, 7, 8, 9, 10, exactly 10 files at a time, unless it complains. And we'll see if it uploads them. That was the other thing I had a problem with. It was dumping. It wasn't uploading everything. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll see what happens. It will tell me error. If the error pops up, that's not a good thing, because it doesn't matter what I do, it won't upload the data. Okay, that's 2 up. Okay, maybe we'll get lucky this week. Yep, 1 just dropped out. Saw a little flash. Here we go. Failed to upload files. Ensure your network settings allow access to the site or contact your network administrator. No idea why that popped up. Unknown error occurred. Okay, so let's see which ones don't pop up, and we'll. So FD001, FD002. Okay, so train 1, train 3, train 4. So one of those has dropped out already. Let's wait until they all come up, and then I'll try to upload whatever's missing. So I would definitely. Oh, there we go. Train 4 died. So I've got. Yeah, gotcha. So train 2 and 4. Test 3. So let's try uploading those one at a time. And if this happens again, I'm just going to have to kill this and start over again. So this is, make sure I get this right. Oh, you pig. Okay, so let's, I think it was test 3, right? Yeah, test 3. See if it uploads it. It's hanging up. Wow. Okay, so let's go ahead now. We're going to get train 2 and 4. Okay, so let's grab. I'm going to do them one at a time. Sorry, we're going to delay just a little bit. Matter of fact, why don't I pause this while I'm getting those up? Well, similar to last week, that was very, very frustrating. So I'm going to try something a little different. What I'm going to do is I am going to see if this works. Which apparently it isn't. Okay. There we go. So I'm going to upload the entire zip file, which was not my original intent. Let's see if it uploads. Or I'll just scrap this and do something completely different. There we go. Okay, so I'm going to open up this and drag this out of the way so I can see what I'm telling it to do. Okay, in this, okay, so let's see, in the zip file, Okay. See. Okay, so what I'm doing here is I'm giving it some detail to train a predictive model. Please use to select the best model. Use the files that start with test to do the testing. The files that start with RUL are the ones that we will use to predict against to provide remaining useful life. Take this one step at a time for demonstration. Will result in a white paper developed as a data scientist. Perform all steps as if you are a data engineer. Ha ha ha. Okay. Show graphics as this develops. Okay, so here we go. Let's see. This is where everything collapsed on me last week. Let's see if it's able to unzip it. It's going to give us some detail. It should be showing my prompt, which it's not. That's not a good sign. Oh, there we go. Okay. Yep. Test data sets, training data sets. Okay, so here we go. Now it's describing what it's doing. So here's the trajectories. It's showing that there's a mismatch, 6 conditions. Okay, each data set contains time series data. The object is to predict remaining useful life each. Okay, next step is to load and inspect one of the training data sets and analyze its structure. Okay, shall we proceed? It just, yes, proceed. And show graphics. Okay, so while it's going through, I want it to show us what that looks like in addition to everything else. And I actually do this with some energy data, and I do this as a quick, let's see what it looks like, what's the best model. I might use MATLAB in parallel with it. In the end, though, I develop my own code. So here's the training data. It's setting it up as basically a table. Okay. So here we go. Time and cycles, operational. Next I'll visualize. So now it's doing that. So it's still working on this part here. So it's a little slow. It is mid-morning on a Saturday, so all the hobbyists are jumping on, playing with it. That's one of the things. I usually try to do my detail work early, because by this evening, it's junk, and then it resets. And then the '01 versions, those are resetting once a week, so mine just reset. Okay. Let's give it time to do what it's promised to do. So here's the data set. So this is part of what you get. Now I can expand this out, which will, whoops, dropped off the edge there. I can expand this out, look across. Okay, sensor measurements. So those are values. I don't know what the values are. Now this is part of the excitement of basically, let's get back to this is part of the excitement of what amounts to anomaly detection. Okay, so in this case, they've classified the types of faults, but a lot of the systems we deal with that are, in our IIoT systems, basically, they don't necessarily know what the labels are, and they don't really know what what anything is. They just know something's deviated, and that calls it out. Now, I have some of that type of stuff going on in some of our cloud platforms, and what we do is we know what the labels are. So I have my team basically go in. We know what we're looking for. We're very specific on it, because anybody that I'm dealing with that touches anything that MotorDoc AI does has to be a subject matter expert and understand what they're looking at. So that's key. So basically, it gave me junk. There's nothing there. Let's see, different engine type, Visualize the time and cycles, so it did not do it. So I'm going to tell it, please redo the sensor measurements graph, which is blank. There should be data from 26 sensors. Okay. So I wanted to give me splash, but it gave me nothing. So that's not normal. Okay, there we go. So it says, oh, there's an issue. So again, this is where you have to understand what you're doing. Otherwise, you go, oops. Okay, I'll process all 19. I thought it was 26 for some reason. There we go again. There's nothing there. Okay, and you notice it also popped up suggestions like, can you see correlations? Well, other than arguing with this thing over this, at this point, I could be going in and doing some data science. As a matter of fact, if you are doing any type of anomaly detection or AI, and you don't have data science work going on as part of it, then you are not really doing AI. I mean, you have to understand the data that you're working with. So, okay, 28 columns, NaN values at the end of each row. First, reload data set, dropping unnecessary columns. Let's see if it comes up with anything. And there we go. So here's our sensor data now. Okay, so what it did is there was data that was bad. So what I've done now is I've said, okay, we're going to clean up the data sets. But what I want to know Now, in reality, I would have opened up the data sets. I would have done my own preparation. That's what data scientists do. It's giving me goals that it wants to provide, because it wants to provide me answers. These are all flat. Okay, fine. But the question is, what was dropped? Okay, and that's where data scientist goes in and needs to understand what's dropped, because the dropped data can result in completely wrong answers. And there's ways to deal with NaN. Okay, not a number, basically. So I want to know what and can the data be estimated based on other data. Now, I'm asking it to do this. This would be something I would do. And in an end model, it's something you can include. That means that if I'm a company and I've set up anomaly detection systems, and I'm looking at anomaly detection stuff going on over a period of time, and I lose a sensor. So, and then it picks back up a couple of cycles later. Well, it could be that it detected something, and I need to understand that as the person who's putting everything together, or it could be that that sensor tripped out for some other reason, and so I can take the data from here and the data here and all the points in between and do kind of an estimate. Now, based upon the type of work that's being done and what happens with it, I can tell it how to do that estimation. Could be a straight line, it could be a couple other things, and it will fill in the missing data. That means I don't get real data, I get estimated data for those points. Okay, and this is something you have to understand, because it's part of the reason why we get false positives and negatives in our confusion matrix. Confusion matrix shows real positives, real negatives, and then where it misses. So all 21 sensor measurements over time for engine 1. 21 now. Okay, so yeah, and then we're going to do one of these before we allow it to do the next step. Okay, we're doing some data science-y stuff, even though we're letting it do the work. There were no missing values. All the columns were fully populated with, okay, so basically it lied to me. It just was giving me an excuse why it wasn't producing stuff. Okay, let's take a look. Let's take a look at the correlations. Okay, it wanted to jump right to RUL, and I'm like, oh, let's visualize the correlations between the different sensors. Okay, and here we go. So correlation coefficient from 0 to 1 and 0 to -1, basically. Red always, because it's against itself. So sensor 1 versus sensor 1 type thing. So these are basically the correlations. I should get red in the middle, meaning, yep, it absolutely correlates. When I come down here, they don't correlate. So they're different types of sensors in different positions and so on. So this is good. I could continue with this, and I would. So from a data science and data engineering standpoint, I would stop at this point and dig deep using different data sets and everything else to fully understand the data. Because, I mean, there's some strange correlations here, this sensor and this sensor. But is it the same across all the sensors? And that helps me look and see if there's a high correlation, then I can use different things. For instance, I could even use a sensor to compensate and verify the data on another sensor. That kind of thing. This sensor says this, but this sensor says it's wrong. And I can use that to create a safety net to reduce my false positives and negatives. I mean, that's one of the problems we have with IoT systems right now, and a lot of the physics-based model systems is, and this is what we learned through some work that has already been performed. The biases and everything else, you want to bias it towards not missing a defect. So you call false positives. Well, if I have a vibration system, for instance, and it's calling false positives on a bearing continuously, and I ran into this with an ESA system. I was called out to see what was going on. They had spent $150,000 trying to correct a problem on this particular system, realigning, motion amplification, this consultant, that consultant, because that AI had to be right, and the people that they were bringing in had to be wrong. So I brought out an ESA device, and I looked at it, and the first thing I looked at the guy and I go, this is on a VFD. Yes. The frequency on the VFD is 35 hertz. Yes. Your physical model, is thinking that this is an across-the-line machine operating at 1785, but it's not. It's reading ground current off of that, which is creating a signature in the signature, and your problem isn't this machine, it's a different one. So we scanned through the machines and we found the actual machine with the problem. In the meantime, this machine learning based or AI based system was sitting over here costing them false positives, which meant they were going, there's a problem with the machine, and it's so critical, meaning it was an environmental requirement, so they had to have this running if they wanted the plant to run. That's how critical the machine was, which is why they were monitoring it. And so they were constantly attempting to repair a good motor. And that can introduce issues as well. So $150K on this. In the other case, I mean, they were detecting a fault, but it wasn't on that machine. It was somewhere else, because nobody understood the details inside the model. They just knew the results that were being thrown at them, and of course they didn't own their own data. So let's see. Do I want to investigate specific sensor correlations? No, we could do this. Literally, it could take days to evaluate it. So let's just say, just so you're aware, I would be digging into this. I would be understanding every aspect of the type of data. Then I would go forward to do the next thing. And that's what we did. Matter of fact, the big project we did where we were looking at estimating 30-day models and everything else, all the research and everything else cost a lot of time and a lot of money and 2.5 years. So, I mean, it wasn't minor. No, nobody had ever done it before, so that's part of the reason. But anybody who says they can walk in and start looking at your data like that, run. Don't walk. Run away. And I don't care how large that corporation is. If they're telling you they can come in and throw stuff at your CMMS system, which we know has perfectly accurate data, and tell you the condition of your entire plant, what they will do is accelerate you to failure faster than you can blink an eye, because this will do that, right? So let's move on to the next step. And we know that. I mean, we talked about that even before all this. Any type of automation system, any type of automated CMMS system in the late 1990s and even in the early 2000s, it's something we were constantly talking about was, if you have a failing system in place and your data is wrong and you're going to fail because of it, automation helps you fail faster. Okay, the next step to prepare the data for predictive modeling is to estimate the remaining useful life. Here's the process. Okay, so this is giving you a chance to verify the process. So it's normalize or standardize the data for sensors and operating settings. Create features based upon, features are what I will be watching. What are the features necessary that are telling me that something's going to happen? Generate relevant features for predictive modeling, such as statistical summaries or of sensor data over the engine's life cycle. And then we'll go into the model selection. Okay, we're just going to go ahead, yes, and provide narrative detail. So here we go. Now, I wish this had happened last week. This would have been awesome. Now, not 4.0, but 0.1, this would be doing some wild stuff with a lot of detail. That's one of the cool things I like about it. Is when I get a chance, after I'm finished the project, after the SMRP conference, I'll use some of that. But I'm in a crunch to make sure I get rid of as many bugs and everything as I can out of the system that we're going to surprise everybody with. Well, I don't think it's going to be that big a surprise, but it's a game changer. Okay, sensor and operational data, feature engineering, and model training. Okay, so I'm waiting for this to pop up. It's running slow, which means all the hobbyists are on board. Here we go. So operational setting. Now you see that the numbers look a little different than the previous numbers, right? Okay, it's done some normalization. It's found a process to take that data and make it something that it can work from. Now, what did it do exactly? Well, let's find out. Okay, so for whenever you see that, and what I did for this, let's go ahead. I'm going to show detail from now on. There we go. So you're going to watch this happen as we go through. Now you're going to see it throwing code up while it's doing work, and then it's going to run that code. So these are the Python. So sklearn is a Python machine learning and AI-based library of code that exists within Python. And so it's going through and it's doing all this stuff, and then it's producing results and everything else. So what we're going to do is we're going to, so it normalized it. It basically made it something that's easier to understand than the messy numbers that we had there before. So from this point on, you're going to see some of that popping up. I just turned it on. I turned it off before because it gets noisy. So shall I proceed with feature engineering? Yes. Okay. So it's going to do rolling averages and standard deviations. Okay. And you notice here, how do rolling averages affect predictions? Which features will improve RUL predictive accuracy? So let's do this. Let's go ahead and have it tell us a few things. Okay. Produces noise reduction. It allows you to capture trends a little easier. It finds, and then improves stability, loss of specificity, and then choosing window size. So it's going to limit us in a couple of things. Do we want to use that, or do we want to explore different approaches? Well, I would be exploring different approaches. This is what data science and data engineering does. So when you're talking about data science, you're talking about data engineering. This is what they do, and it's a it's a lot of statistics, it's a lot of everything else. If you're a reliability engineer, you should be really familiar with this type of approach, because that's basically what we're supposed to be doing, right? So use rolling average and proceed. Okay, so we're just going to do that because I'm taking up a lot of your time. So here we go. So now we're going in here. So it's selecting the window size. It's doing a rolling average. So here's its steps. Before we were just watching it. So it's giving me now a little bit of code. A lot of the steps are built into the code. Okay, so you can see it's going da-da-da-da. There we go. It's pulling out the features. There's the training data with the rolling averages. Okay, so use train data, train text files for training, and test files for testing. Okay, so what it was about to do, because train test split, it was going to use that specific file and split it up to see if it could predict things. but we want to use the training. We want to get it to stay on track. Okay, so and there's other things you can see. It's suggestions like, how does this happen? How does that happen? And it basically, you do something like this. If you're just learning how this works, instead of going and following along with the course, explore. I mean, literally, this is still the Wild West, folks. This is it used to be the realm of engineering and academia, right? Back in the day, I had to go work for people that had a computer that was able to do this level of work. And now, okay, so I'll load all the training data, test the model against that. So here it is. It's putting together the code for me to do it. You can see there's nans hiding in there. Not a number, meaning blank. Okay. I'm just waiting for it. Well, you know what? Let's go ahead. I know what it's going to look like. We'll go back to it as soon as it's finished. It's processing a whole lot of data. And, of course, everything's being bogged down with everybody having fun with AI right now. So we're going to have to wait for it to finish that. Then it's going to start doing the other. We're probably going to go another, say, probably half hour on this. Okay, you know what? I am going to pause real quick because this is taking a little longer than I expected. But let me go ahead and have a quick discussion. So what it's doing right now is it's going through and it's processed these sensors. And the reason why it's spending some time here is because we have all of those areas that say not a number or nan, and it's got to try to manage that. And it may come back and it may go, arg, I can't do it. By the way, anywhere where it shows this down arrow, that gives you the ability to download that data. It'll usually download CSVs. So I could download that table for doing work later on. A lot of this is becoming extremely interactive. Even when I go back here to one of the images, like this, it'll download that as a PNG file. Web-based file. So it'll be an image. And in some cases, there'll be some types of images where, like if I do a fast Fourier transform or something like that, where I can actually interact with it. So I'm going to go ahead and pause and let this thing run and fill my coffee, and we'll be back in a minute. Okay, what it did is it was unable to, but basically it was just too much data to display. So let's go ahead and we will proceed with normalizing the test data sets. Now this is a chat. It's ChatGPT. So basically you're chatting with it. So it's remembering things. This is one of the problems with this is people assume that it's conscious or it's thinking somehow because it's designed to run a narrative, right? Much like Alexa and all these other tools that we have where you can have a conversation. Matter of fact, there's a version of ChatGPT where you can have a conversation with it on your phone, but it's not a conscious entity. It's just providing prompted data. So here we go. It's taken all the data sets. It's done all this. Okay. I'll test data with rolling averages, remaining useful life data. And that's key to remember, right? So here's its predictions. Let's see if it gives me good graphics here. Okay, so test data with rolling averages, and then remaining useful life data. If it takes more than another minute, I'll pause it again. That last waiting for that to do what it did took a little bit. So let's see how it goes. It should be showing me a graph of towards failure times. So I will pause and let it run. Okay, as I'd mentioned, everything completely fell apart. And that's not unusual. I mean, redoing this type of thing happens over and over again. So I basically said, just start over. So let's see what it does. We'll see if it errors or not. I really just want to show the graph. Okay. You should now see the plotted graph is not showing still. Ran into this last week too. Unclear why. It has to do with this data set. Because I've been doing some other things and haven't had a problem. Now it's going to start throwing the errors again. So, welcome to ChatGPT. Don't be surprised. Now, what I could do from this standpoint is, here we go. Now it's going to lock everything up again, and here come the errors. Is back here, take this and run it through, actual data. And it's still just using just the son of a gun. So it decided to skip all of my instructions and go on and do what it wanted to. Welcome to generative AI. So we're going to stop at this point. I think the lesson's learned. Next week, we're going to do a true predictive model. I'm going to actually generate it, and we're going to walk through step by step in a Python, in a Jupyter notebook. So it'll be section by section by section, and I'll show you how this can proceed. But people that really rely on, here we go, exactly what happened before, it will not show the graph, and then it's going to end and say, oh, it's because we had interruptions and we lost all the data and everything else. This evening it might work perfectly. Tomorrow morning it might work a different way. But it's going to approach it completely differently than we did just now. I made a lot further than I did last week. We've spent an hour and 10 minutes on this. Let me pause. I just want to show what I was hoping to see, and I'm going to put that together in Excel. So hold on. So I'm going to end it on just this note real quick. So what I did is I just took raw data, threw it in, told it to do a KNN. It still didn't produce exactly what I was looking for. Again, it is really, really, nearly impossible to get what you want out of a generative AI, even when you're using generative AI to develop your predictive AI. And this is a good demonstration of that. So for those who watched, welcome to AI. So I went ahead and ran it. I wanted to get the graphics that we're going to display. I suspected what it was doing, and it did. So I just told it, give me 5 random engines, give me all the sensor data. It still decided that it didn't need to listen to me. And the reason it kept running into the NANDs as well. So this is sensor 1. I wanted all of them, but so it starts here, 0, and it runs out. And this is the point of failure there. The test data to test against this comes out, and the failure is at this point, okay, the expected one, and it wasn't able to run a RUL at all on the RUL data. So RUL data actually gives an answer compared to the test data. So these are the 5. It, again, did not provide exactly what I was looking for. That's a prompt issue. So that means I should have been a little more specific on what I was looking for. But overall, yeah. So what we're going to do next week is I'm going to have a pre-done predictive analytics set up, and we're going to walk through. It'll be vibration. I believe the set I'm going to use is vibration data on bearings. So we're going to do some sets on that so you can see what something is that relates to what we're doing and how it's supposed to work as far as a predictive model. Now, let me just do this, and I'm going to have it run through and give me a quick list. How many and what are the time series predictive models? So just a list. Let's see if it does this for me. Yeah, it slowed to a crawl today, which means I'm going to be having fun when I get back to my programming stuff this afternoon. Okay, we'll pause.